Good day, viewers all over the world. You are welcome to Toilet online class. Today, we want to find the sum of GP, of geometric progression or exponential sequence. Another sum of GP, there are three conditions or three formulas that we have. The first one is that when the sum can be equal to A into bracket Rn minus 1 all over R minus 1 when R is greater than 1. The sum can also be equal to A into bracket 1 minus R raised by N all over 1 minus R when R is less than 1. Then we can have sum to infinity to be A all over 1 minus R. So these are the three formulas that we have under sum of GP. So it is the nature, it is the value of R that will actually determine the formula that we are going to apply. So let's look at this example. There are two examples on the board. We want to find the sum of this GP. So there is need for us to find R. Once we know R, that's when we can actually find the sum to GP, the sum of the GP. So now let's look at the first one. Look at the first question. Find the sum of the following GPs. The first one, look at that first one. We are given we know the first time, we know the last time. Of course, we can know the number of times that we have in that sequence. Solution. To be able to find the sum of this GP, we must know n, the number of times that we have. Of course, A is the first term. A is the first term. If you look at it very well, then what will be the common ratio? Look at the first and second. R can be equal to 3 divided by 1. Or it can be equal to 9 divided by 3. And it's equal to 3. So we know the common ratio. So how do we now get the number of terms that we have in that sequence? The number of terms in that sequence, of course, we know the last term. The last term of that sequence is 729. So we can use the formula to find the last term of a geometric progression, which is given as AR raised by n minus 1. So we know L, the last term, to be 729 is equal to A, first time is 1, multiplied by R is 3, multiplied by 3 into bracket n minus 1. Then we are going to have 729 here to be equal to 3 raised by n minus 1. Can we change 729 as an index of 3? Yes. Then 3 raised by 6 is 729. 3 in 6 places. So 3 raised by 6 is equal to 729. That's 729. Then this will be same thing as 3 into bracket n minus 1. The base are equal, we equate the power. We have 6 is equal to n minus 1. Then 6 plus 1 is equal to n. So n is equal to 7. So we now know the number of terms in that sequence. So if the number of terms in the sequence is 7, then we can go ahead and find the sum of the first question. So what would that be? So in this case now, what is the value of R? R is greater than 1. So the sum will now be A into bracket R raised by n minus 1 all over R minus 1. That's the formula that we're going to apply in this first question. So we are going to have A is 1 into bracket 3 raised by n is 7 minus 1 all over 3 minus 1. So here we are going to have 3 raised by 7 minus 1 all over 2. So what is 3 raised by 7? That will be 729 multiplied by 3. And that will give us 2187. So here we are going to have 2187 minus 1 all over 2. And that will be 2186 all over 2. And this will give us, the sum is going to give us 1043. So for the A part of the question, that is what we are going to get. So let's look at the B part of the question. Of course, we are going to look at this. Look at the B part of the question. What is the first term? A is equal to 45. Then what is common ratio? Because this is also a geometric progression. First term, second term, that is 30 divided by 45 or 20 divided by 30. Irrespective of the one we decide to choose, we are going to get the same thing. So that will be 30 divided by 45. And that will be, of course, 15 here is 2. It's 2 over 3. So 2 over 3 is less than, 2 over 3 is actually less than 1. So we are going to apply the second formula, that is, the sum here, we are going to apply it to be A into bracket 1 minus R raised by n all over 1 minus R. And that's what we are going to have here. So in this case now, from there, the sum can be equal to A is 45. So we have 45 into bracket 1 minus 2 all over 3 raised to power n, in this case now, n, we have to find out the sum. We have to find the sum as far as the system. So n is equal to 6. So n is equal to 6. Okay, that's what you are going to get there. All over 1 minus 2 over 3. So what is 1 minus 2 over 3? This same thing as we have 45 into bracket 1 minus 2 all over 3 raised by 6. Then all over 1 minus 2 over 3 is 1/3. Of course, if we say divided by 1/3, this 3 can come up. So that at the end of the day, we are going to have 3 multiplied by 45 into bracket 1 minus 2